All right, so we finished number 7, but what if you saw this as really a quotient rule? You know, I mean, it's possible you see this and you think quotient. So let's go over here and talk about how we could take the derivative of that, thinking about the top as the constant 1, and we got the bottom as this actual f of x. If we take the bottom, so that is like our g, right? So we take the bottom times the derivative of the top minus the top times the derivative of the bottom, and then all over the bottom squared. What you're going to find is that 0 times the anything out front disappears, and what you have left, let me highlight this right here, that is the same thing as what we have right here. So you have the opposite of f prime of x, and you have f of x quantity squared. So, you know, there's no harm if you saw that as a quotient rule to start. It's up to you. Either way, it doesn't matter. All right, let's move on to number 8. So in number 8, what we have here is a power. We've got a power of 4, and then we got some stuff inside it. So we're going to start with that 4 coming down, change that to a 3. Okay, and then the inside stuff, that 2x squared plus 1, that was this business. It doesn't change. All right, and then we need to multiply by the derivative of that inside. So we'll go 4x because that's the derivative of that inside stuff right there. And this is actually your answer, but let's rewrite it. We can put the 4x times the 4 out front. That would be 16x. And then we got the stuff to the third power. So we're looking for something with a 16x out front. And no, and no, and no, and no. And it looks like it's going to be E right here. All right, so that's it for that one. All right, moving on. Next question. Number 9, find the equation of the tangent line, not just the slope of the tangent. We want the equation of the tangent line to the graph of y equals cosine plus tan 2x. Okay, so what we're going to need is we're going to need a point, and that's going to be x comma y of x. And then we need the slope, which is going to come from y prime of x. All right, so let's start with the point. So we're going to go plug in 0. So we're going to get cosine of 0 plus tangent of 2 times 0 is still a 0. We know cosine of 0 is 1 and tangent of 0 is 0, so we get a 1. So that means we have the point 0, 1. So already we know this much. Y minus the 1 equals the slope, which we'll put in here later, times x minus the 0. So now we're going to go find the slope. So let's do that over here. So slope comes from the derivative of this right here. So we'll start with the y prime. We're going to get negative sine of x, and we got a little chain rule right here. We get secant squared of the 2x, but then we have to multiply by a 2 because the chain rule. All right, so now we're going to go plug in our 0. So we're going to get negative sine of 0, which we know is 0. And then this secant squared, remember, that's the same as 1 over cosine. And let's go ahead and plug in the 0 there, and we'll do the squaring down here. So remember, secant is 1 over cosine. So if this thing is squared, so is that thing. So I went ahead and flipped over a cosine, and now we're going to go find the cosine of 0. We know sine of 0 is 0. So we have 2 on the top, and then we have cosine of 0, which is 1 squared, which is 1, which is 2. So that's the slope of the tangent line. Now that we've got that, we can go put a 2 right here. So this is a fine answer. You can leave that. It's point slope form. If you really wanted to, you could go rewrite it in slope intercept form. 2x minus nothing plus the 1 comes over. Anything like that would be good. All right, just double checking. I want to see if I get the same answer before. I did. All right, that's it for number 9. All right, next week. Next problem, number 10. So I'm looking at the derivative of v with respect to r. So you can pretend like those are y's and x's if you want. All right, let me change that up. Let's use some different colors here. So think of this as y equals 3/4 pi x cubed. You would do the derivative just the usual way, it would be dy dx equals 3 out front, and then you got your 3 over 4 pi. That's a constant right there. That doesn't change. And then you would reduce the power. Well, same concept, but we have dv dr. So dv dr will be very similar to that. We're going to go 3, and then you got your 3/4 pi stuff to the second, right? So we reduce the power. And then from there we can clean that up a little bit. That's 9 pi over 4 r squared. And then we want to go evaluate that at r equals 2. So that just means plug in a 2 and square it. That gets me a 4, and the 4's cancel, and final answer is a nice clean 9 pi. Not too bad of a question. It's a little confusing at first if you're not used to those variables, but we'll get used to those. All right, next up we need to find the derivative of f the long way. So that means f prime of x. We'll start with a limit. Okay, next we have h going to 0. We're going to do our x plus h squared minus x plus h. That's the first pile, minus the function itself, all over h. As a reminder, this right here is f of x plus h, and this is minus f of x. That's your formula. So yeah, now it's time to go ahead and start working it out. So keep the limit going. Nice notation is always important. Then we got to FOIL this out. X squared plus 2hx plus h squared. We're going to distribute this negative, minus x minus h. Go ahead and distribute that negative, and we should see some nice cancellations on top. So let's go ahead and go through our cancellations here. X squareds are gone because they're opposite signs. X's are gone because they're opposite signs. The leftover stuff, this, and this. And you'll notice right away that all three of those terms, they have an h in them. So we're going to factor out the h, and we'll leave a 2x plus h minus 1. And that'll be really helpful because now it's time to go cancel those h's. So cleaning this up, we have a very simple limit left of 2x plus h minus 1. H is going to 0. We'll let h actually become 0, and you are, nope, not a plus. That'll be a minus. So we are done. 2x minus 1. And if you look back to the original, I think it's pretty obvious that the derivative of x squared minus x is 2x minus 1. And we are good to go. Next up, number 12. All right, the derivative y prime is just a repeater, and it's a negative repeater. And there we go. Let's see. For the second derivative, what we're going to do is recognize that we have a product here. Let me highlight these separately. So we got this guy, and we got that guy. So that's a product rule. So to find y double prime, we're going to go, let's see here, that's supposed to be a double prime. We're going to go g, and then f prime, which is the derivative of negative cosecant. So it was a negative, and now it's going to change sign, so it'll become a positive. Cosecant x cotangent x, plus, then we take the f, which is negative cosecant x, and we multiply by the derivative of g, which is negative cosecant squared of x. As a little reminder, if you do not know all of your 6 trig derivatives, memorize those, right? I can't stress that enough. If you don't know those, you can't do the tougher problems that just involve that as one little minor step. So then we're going to go multiply your cotangents together, make them squared, and then you got a minus and a minus, multiply to get a plus, but that is going to be a cosecant cubed out there. And that is a pretty good looking answer right there. There are other options. So one of them would be to factor out the cosecant. That's probably pretty obvious to you. If you do that, you get cotangent squared plus cosecant squared. So that's not too bad of an answer form right there. There's so many different forms. If you wanted to swap out a cosecant squared, we got lots of ways to do that. You can swap out the cotangent squared if you like. We're not going to go through all of those in this one video, but feel free to ask me when you see me next time if you got questions about that. All right, number 13. We're going for average rate of change. As soon as you hear that, you're thinking slope of the secant line. And that means we're going to go with y of 6 minus y of 2, because they gave me the x values right there, over 6 minus 2. So the y of 6, let's go calculate that up here. That's just 6 squared plus 1. It's 37. And then y of 2 is going to be 2 squared plus 1, which is a 5. So we'll subtract 5 up there. So we'll get 32 over 4, which is 8. And we are done. Average rate of change, same thing as slope of the secant line. And there you have it. You're basically finding old style slope. Second part of that, we're looking for the instantaneous, that means slope of the tangent line. So now we're just going to go take the derivative. That means y prime of x. Well, that just means 2x. And then they said to go plug in 3. When x equals negative 3, negative 3. So we'll go plug in the negative 3. And it's as simple as that. Don't be tripped up by this weird wording, instantaneous rate of change. That means derivative. That means slope of the tangent line. All right, we're done with number 13. Moving on to 14. We've got a whole bunch of derivatives here. See if we can crank a bunch of them out. So we'll go y prime. That'll be a 30x to the 4th minus the 1. The constant goes away. And we are done with the first one. Next one, number 15. This is not a product. This is cotangent of the 2x minus 1. Some people see the 10 as an f, and that's a g over there, but that's not necessary. It really isn't. I always talk about leaving the 10 out on the porch. Well, you can do that right now. 10's out on the porch. Derivative of cotangent is a negative cosecant squared of its stuff. Don't change its stuff. But also don't forget to multiply by the derivative of its stuff. All right. So next, we can just clean that up a little bit. We can take the 10 and the negative 1 and the 2, multiply those all together, and we'll get ourselves a negative 20. And then we still have the cosecant squared of 2x minus 1. Final answer right there. Moving on, number 16. Pretty simple look. I'm going to go with a different style here. We'll go dy dx this time. The negative 7 comes down and multiplies by the 5. Then we reduce the power. This is a very common mistake right here. Is it going to be negative 6 or is it going to be negative 8? Well, if you remember, you're supposed to subtract 1 every time, and that leads us to the negative 8. Final answer. If you would like, you can go ahead and move the x to the negative 8 down and make it a positive power. So either way, we like either form of that. All right, next up, we're going to do a rewrite. This is not a cosine times 2x to the 4th. It's a cosine of 2x to the 4th. But more importantly, I want you to see that the cosine function is being cubed. So we got this function inside it. That would be a 2x to the 4th. But cosine is being cubed out there. All right, so let's take the derivative of the outside. That would be the stuff to the 3rd up here. So that's going to be a 3 stuff to the 2nd. And then we're not going to change that cosine. We're not going to change the 2x to the 4th. None of that stuff changes. However, we do need to multiply by the derivative of the inside. Now, the inside function has 2 parts to it. There's the outside cosine. There's the inside 2x to the 4th. So we're going to start with the outside of that mess. That'll be negative sine of the stuff. And there's that same old 2x to the 4th, and it's not changing. And now it's times the derivative of that stuff, 8x cubed. All right, there's a lot going on here. So now it's time to clean it up a little bit. Take the 3, take the negative sign, take the 8x cubed. Let's put it all together. We'll put that out front. So that will lead us to negative. 8 times 3 is 24. The algebra comes next, x cubed. Next, we have a cosine function and we have a sine function. It doesn't really matter which ones you put first. I'm going to put cosine squared of 2x to the 4th, and then we'll have the sine after that of 2x to the 4th. And that is a fine looking answer right there. Okay, we can just leave it like that. Now, if you reverse the order of these, that's great. It doesn't matter. But notice we do have a squared on the cosine, not on the sine. All right, I think we're going to have to stop it right there. We will pick up in the next video. All right, thanks for watching, guys. Hope this is helping.